Hello everyone. In this video, we will learn how to divide distinct objects into distinguishable groups. Okay, so we will start with one example. We have 10 different books and we want to give 3 of them to A, 3 of them to B, and 3 of them to C. In how many different ways we can do this. Okay, as you see, well, this can be divided into 3 steps. So in step 1, we choose 3 books out of 10. Choose 3 out of all books to give them to A. Why? How many ways we can do this? Okay, we have 10 books. We choose 3 of them, not 4. Then step 2. Now it's turn for choosing books for C. So choose 3 out of remaining books. Yes, 3 of them I already gave to A. So out of 7 remaining books, to give them to B now. So there were 7 left, so we choose 3 of them. And the last step is step 3. Well, choose 4 books out of all the remaining ones. So 3 to A, 3 to B. There are 4 left. Well, we basically give all of them to C. Well, this you can write either 4, choose 4, or okay, there's only one way. The remaining, you just give them all to C. Okay, so now the total number then ways this can be done is equal fundamental counting principle, yes? So you multiply these ones, and then there's 1 there, so I won't do much. But I want to show you a calculation here. So 10 choose 3 is 10 factorial, 10 minus 3 factorial, 3 factorial, then 7 factorial, and then 7 minus 3 factorial, and then 3 factorial. As you can see, okay, so let me do one more step here. This will give me 10 factorial, 7 factorial, 7 factorial, 3 factorial, 4 factorial, 3 factorial. And then you can cancel those 7 factorials, and the result is 10 factorial, 3 factorial, 3 factorial, and then 4 factorial. This is not by chance like that. We can do exactly the same steps in general to find in how many ways we can define n distinct objects into multiple groups. Okay, so the number of ways, so the number of ways that n, there must be distinct objects can be divided into multiple distinguishable, so distinguishable groups, such that n1 for group 1, n2 for group 2, and well, this will go up to nk for group k. This number is given by, as I said, you can do exactly same argument, n factorial divided by n1 factorial, n2 factorial, n3 factorial, and this will go up to nk factorial. Well, since we divided everything into these groups, then we have to know that, well, the sum of the number of the members of the groups must be equal to the total number, yes? So this is the formula that you should have in mind. But like before, the notation that the number that you see here we will see so many times that we will fix a notation for that. So notation, if n1 plus n2 up to nk, they add up to n, all positive integers, then the number that we just found up there, n factorial, n1 factorial, n2 factorial, nk factorial, we have a notation for that. This notation is like choosing notation or binomial coefficient notation. We put n up there, n1, n2, and this will go a list of numbers up to nk. Well, before we called the other one binomial, but now there are more than one, and this is where we call this one multinomial coefficient. And there is a relation between multinomial and binomial notation. So note that well, remember that when you have n objects and you choose k of them, what happens? You may say that I'm choosing only k, but in fact you're choosing two groups, one k and the remaining one, yes? So the formula also says that this is a group of k and the rest. But we can write this in terms of multinomial coefficients. This is n, I'm choosing n minus k for the first group, and k for the second group. And that is the relation. Basically, when there is one index in the lower spot, then that's binomial. But if you translate it in multinomial case, you have to put both of them so that they add up to n. And now let's go back up there again, look at that problem that we had. Well, that number is 10, choose 3, 4, and 3. You will see this notation appearing several times during the course, but for now you have to understand this and you have to be able to use it. Okay, so let's finish video with some examples. So here I have a history class. There are 18 students in this class, and we want to divide them into 3 groups of 6 and assign 3 topics: World War I, World War II, and Cold War. In how many ways this can be done if each group must be assigned to different topics? Okay, so basically here we have 3 groups. What are the groups here? Well, the group that will do World War One, the other group World War Two, and the third one Cold War. Yes. Now, you choose. You have 18 of these ones. For group 1, which is World War 1, for group 2, World War 2, and Cold War, there are 6 students for this one we want to put, 6 students for that, and 6 students there. That is the number of ways we can do it. If you like, this will be 18 factorial, 6 factorial, 6 factorial, 6 factorial. Okay. The other example has the same, well, it's in the same context. We have 18 students. There are 3 topics, and we want to make 3 groups of 6 to cover these ones. But we want something more also. From each group, a student will be chosen to present the work of that group. Okay, so here, first of all, we have so far done step 1, which was make the groups. But then you have to choose a representative or representer. Choose a person from each group to present. Okay, so the first one we have done. There are 18 students. We want to put 6 of them for the World War One, 6 of them for World War Two, and 6 of them for Cold War. In step 2, you see we have a World War One, World War Two, and Cold War. Let me just CW groups. Each of them, we have to choose one student out of those members of those groups. Well, there are 6 possible ones for World War One, which you can write 6, choose one, or just simply 6. There are 6 choices for World War Two and 6 choices for World War Three. So in total, this will be, well, product of all these things. Well, 6 choose 1 is just 6 times 6 times 6. And that is 18, 6, 6, 6, and then 6 to the power 3. Okay, so you will see different versions of this thing, but the key point is that when you have the number of groups and the groups are fixed, World War One, World War Two, and so on, then you can use this formula to find number of ways we can divide n distinct objects into these multiple groups.